Here is a question from Combinatorics. So for this one, you must remember the formula. nPr equals n factorial over n minus r factorial. So this is n and this is r. So to solve this, I'm going to just apply nPr to find np2. So therefore, I'm going to have n factorial over n minus 2 factorial according to my formula equals 9n. Now the trick after this is just you want to expand this, because n factorial, or any number, if you have like 8 factorial, it means 8 times 7 times 6 times all the way to 1, 8 times 7 times 6 all the way to 1. And so what you do when you're minusing 1 every time, and that's what you're multiplying together. So I'm going to take this one on top and expand it that way. So I'm going to have n and then n minus 1 and then n minus 2. But I'm going to put factorial right here because the bottom is n minus 2 factorial. And that way I could cancel and get rid of that factorial sign, and then I have 9n on the side. Now I could solve this by expanding and then bringing everything to one side, equating it to 0. So therefore, I'm going to have n squared minus n when I expand this, when I distribute this in here, equals 9n, n squared minus 10n, because when you move the 9n, it becomes minus. So negative 1 minus 9 is negative 10n equals 0. Factor out n, and you get n minus 10 equals 0. And therefore, n equals 0 and 10. Of course, you're going to reject the 0. You cannot choose anything from 0. If you have 0, you cannot choose anything from it. So n equals 10 for this question. This question usually worth about 3 marks. I think easy 3 marks if you know this formula. Let's move on to the next question. Here's another question, topic that I haven't covered yet in my lecture series with Pre-Calc 12. I will get there eventually. Now, this is determine algebraically the value of the leading coefficient of the graph of the polynomial function of p of x. So now the first thing you want to do here, you definitely want to write your zeros. So the first 0 you have there is x minus equals negative 3, multiplicity of 1, x equals negative 1. It's a multiplicity of 3. M stands for multiplicity. And then you have x equals 1, and that's multiplicity of 1. Now you could ask me, why is it multiplicity of 1 and why it's multiplicity of 3? Multiplicity of 1, if your curve goes right through the 0, it's a multiplicity of 1. If it goes through it for a bit longer, it's a multiplicity of 3. If it bounces, it's a multiplicity of 2, but we'll deal with that when we get there. We don't have that in there, so just get rid of it. Also, we have a y-intercept. That is negative 12. So basically, I have a point at 0 and negative 12 that I'm going to use ahead to find out what my leading coefficient is. So if I start writing the answer for this right here, I'm going to write y equals a x plus 3 x plus 1. And when I write plus x plus 1, because it's a multiplicity of 3, it means it has an exponent of 3. That's what it means. And then I have x minus 1. Now I'm going to use this point 0 and negative 12 to solve for a. So negative 12 equals a sub 0 for the x, because that's what x value is, the x coordinate is, plus 3, 0 plus 1 cubed, 0 minus 1. Negative 12 equals a. 0 plus 3 is 3. 0 plus 1 is 1. 1 cubed is 1. If you wish, I'll just write the step. 1 cubed is just going to be 1 and then negative 1. So negative 12 equals 3 times 1 is 3 times negative 3 is negative 3. So that gives me negative 3a. divide both sides by -3. Therefore, a equals 4. My answer is y equals 4, x plus 3, x plus 1 cubed, and x minus 1. That's your final answer right there for this one.